Section 7 is just going to run through a couple of miscellaneous things that we kind of close out part 2. One is that table that I keep bringing back, because now we can add one more piece to it. When we were talking about symmetric versus skewed data and what measure to use for center or spread, which as I said is always a test question, we've got this down, right? Center, I like to start with the skewed distribution because it's a lot easier to see. If we have outliers or a skewed distribution, we know the median is going to be a better measurement. It's going to ignore those outliers because it's only looking at the middle value. Same thing with spread. We want to look at the IQR because if we're only looking at that middle 50%, well, we're ignoring anything in the top 25 or bottom 25, which would include a tail or outliers. For symmetric data, that's when we get to use the mean and the standard deviation. Both of these measures look at every single data value, so they have a lot more information in them. The only issue is we shouldn't use them if some of that information is potentially problematic and going to skew our results. All right, so then we have our outliers. Think about our different formulas and ways that we've tested for outliers. For box plots, we use the fences, right? The fences, this was Q1 minus 1.5 IQR, and Q3 plus 1 point. This involves the IQR, right? Just like the IQR is the difference in the medians of the upper and lower half. All of these things are tied together. They all are stuff you're going to see in a box plot, right? Whereas for symmetric data, our best bet in terms of checking for outliers is using those z-scores, which use the mean and standard deviation to see how far an observation is from the mean. So just adding one more piece to that table we've been playing with. We have two more little examples here. One is a little bit more on outliers. Just because we find something as an outlier using the z-scores or the fences doesn't mean we can just toss it out. If we can prove that it's an error or we can confirm that it's an error, definitely. This brings me back to another story from when I was at UCSD. Obviously with those blood glucose measurements, there was nothing that was erroneous about those measurements. So we actually just did sort of, if you look at the next piece here, it says, don't leave the outlier in place and without comment, and don't drop it without comment. So we actually tried both ways. We did the same analysis with all of the people with really high blood glucose measurements and without all the people with really high blood glucose measurements. And if you're lucky and your method you used is robust, then you're not going to see much of a difference in the conclusions. And if there's no difference in the conclusions, then it doesn't really matter. But if there is a difference, then you have to justify why you included or excluded those outliers, which is always a little problematic in terms of making conclusions. But sometimes you can prove there an error. One time at UCSD, I went and did a histogram of weight, because that's the first thing you want to do when you're looking at your data to make sure it's clean, is just do a quick histogram. So I did a histogram for weight, and this is what it looked like. Okay, 100, 200, 300, blah, dot, 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 all the way over to 900 to 1,000. There was a big bar from 100 to 200, a little bar from 200 to 300, and then another small bar from 900 to 1,000. And I immediately saw this and went, WTF. How is there anybody in this 900 to 1,000 range, especially considering these people have to travel to us, get in an MRI machine. There's a lot to do in this study. I'm pretty sure they couldn't make it if they were actually in this range. And so I looked at my data, and it turned out, yeah, sure enough, I had about 10, 15 people who had weights that were exactly 999. So I went up to the postdoc who I worked with and was like, what is happening here? And it turned out that one of the old programs they use coded missing values with just repeating nines instead of an NA or some other, or just missing blank. So I had to realize, oh crap, those are not real. I need to delete all of them. But if I had just done analyses without looking at my data first, my regression and everything else I was doing would not have made any sense. So this is part of the reason why we look at our data first, and if there are outliers, figure out, is my method going to work for them? Are things going to be different if I include them? And if possible, can I recognize that, oh, that's just supposed to be missing data, let me recode it. And then there's an example of when discarding outliers actually got people into a lot of trouble, which you can read, but I will not read to you. The last thing in 2.7 is this idea about time plots. It's just another way to display data. This we actually saw at the end of those examples that we saw at the beginning with the cheese and getting tangled in bed sheets. Just the idea of how something changes over time. So this is another 2-variable sort of question, right? We're looking at 1 variable over time. So it is 2 variables because we have time and we have another variable. But you can imagine this being particularly useful in like a perspective study. Never going to see any questions about time plots on an exam. I mean, I guess I could put one on like this last one, sort of ask you what different trends are you seeing in the residential power demand. And if you glance at this, hopefully you see this sort of cyclical pattern and you go, what's causing that? It looks like there's peaks, and the peaks are always in this like May to September. Oh, we have peak usage in summer. And beyond that cyclical trend, you can also see it looks like we're overall, there's an increase in usage or demand. So I could give you something like that. I have never, but you know, it's well within things that I think you guys are capable of. So that's it for part 2. Yep, after that we just get to the sample problems, and we'll get to jump into part 3, which we'll start on Wednesday or Friday, depending on what class you're in.